Mr. Prasoon Bandyopadhyay. He's an architect with 6 years of experience in IT parks, institutional spaces and retail design. He graduated in the year 2011 from National Institute of Technology, Patna. He joined L&T Construction in 2011 and worked in various multi-million projects spanning from various IT parks to institutional spaces. Presently, he serves as a lead architect at Future Research Design Company.
Welcome to UGC lecture series. I am going to take construction technology AR6013 and this is lecture 1. In this lecture we would go through the construction systems. This is the unit 1. In this lecture we would start with environment. We would have a definition of built and natural environment. We would go through the elements of built environment. We will move to structure. We will go through the various types of structure. We will go through each and every component parts and functions of each of these components of structure. We would go through the concept of internal separation and compartmentation. We will start with environment. Environment can be man-made and natural. We will start with surroundings. That is, surroundings can be natural, man-made or combination of these. A built environment is an environment that is created by man or with the aid of natural environment. Here in this illustration, we can see the elements of a natural environment. We can see the trees, we can see the shrubs, we can see the waterways, we can see this. So, all these constitutes of natural environment, whereas a built environment consists of daylight ventilation mechanisms, artificial lights, textures, an envelope in which the human beings, a man resides in, a circulation space, furniture for people to sit. So, all this consists of the built environment. Now, a surrounding is a composition of these natural and built environments. You can see in this illustration there is a building here, that is a man-made environment. These are the paved areas, that is again a man-made environment. These are the walls, that is again a component of a man-made environment. These are the retaining walls here. Then these are the plantation. Then these are the lakes. All these are the components of the natural environment. Then these are the trees, shrubs and vegetations. So, all these together are called as surroundings. So, all these together defines the space around us. So, this is what is environment. Coming to the structure. What is a structure? A structure is an arrangement and organization of interrelated elements in a material object or system or a built environment. A structure is nothing. A structure is an arrangement of small composites. So, a structural system, and these composites are also called as structural system. To go through the definitions of structural system, the structural system refers to load resisting subsystem of a structure. The structural system transfers the loads through interconnected structural components or members. So, these structural systems and the structures can be classified into various types. If you see the illustrations in this slide, this is a simply supported beam. So, this consists of a beam and two supporting walls. For design purposes, ends are assumed to be free, that is, these are not fixed. So, this structure, a small example of a structure, is called a simply supported beam structure. The next is a built-in beam. In this, what we do? This is a beam and there are supporting walls. For design purposes, the ends are assumed to have some degree or fixity. The next composition is a cantilever beam, in which we have a beam which is supported or fixed at one end only. So, this becomes a cantilever beam. This is also another kind of a structure. Then it is a propped cantilever structure. We have a supported or fixed beam at one end and the other end is propped at the free end. So, this becomes a propped cantilever structure. A structure consists of various members. So, these members are the structural members which do an important task of transferring the load from one member to other member. It is basically how we transfer the forces from one member to the other member. So here we see an example of a strut. A strut is a structural member which is subjected mainly to compression forces. Here we see a column, and this column can be called as a vertical strut. Here we see there are forces applied by this slab, there are forces applied by the bottom slab, and this column is doing a work of strut, of transferring the forces from one place to the other place. So this vertical strut is also called a column stanchion or a pier. This arrangement of structure is actually a rafter and tie structure. Here we see we have two rafters and this is a tie. So a tie is a structural member which is subjected mainly to tension forces. Here we see arches. Now arches, they transmit load around, the load is transmitted around the arches to the abutments. So here we see the load is applied here and the load is further brought down from two sides like this. So these are the abutments and the load is applied here, and the load is further transferred to the ground by these along the curves. So arches are a very important structural component. Next is a post and lintel system. In this we see there is a lintel that can be a simply supported beam, that can also be called as a simply supported beam, and then there are two posts. So what happens is when the load is applied here and these are further transferred to the vertical members, that is those vertical members are called the posts, or we also call it columns. In this frame, this is a frame structure. In this frame we see a combination of a rafter, a tie and a strut. We see we will come across more of it, of how the load is distributed in the subsequent slides, but what we see is, these are the rafters, this is a tie, and these are the struts. So it's a combination of the structural members that we have gone through previously. Now the classification of structure can also be termed in the types of construction. Here I bring to you an example of solid construction and a framed or skeletal construction. In solid construction, what happens is the load of the roof is transferred to the ground through load bearing walls. So the solid construction is generally done in those areas where it is usually where the buildings are confined to low height and very short spans, and this is a framed or skeletal construction. In this construction comprises of main beams, secondary beams, edge beams, tie beams, etc. So it's a basically framework of beams and columns by which the load of the roof is brought down to the foundation. There are again two other types of construction. One is a panel or box construction and the other one is a folded plate construction. Here we see in the panel or box construction, this structure consists of a series of interconnected plates forming structural walls and floors. In the folded plate construction, the flat slab is folded so that the roof will behave as a beam spanning along the fold, and then we have a diaphragm introduced into the folds, and there you see here the columns are under the diaphragms so that those columns can take the load down into the foundation. Other structures like the shell roofs are formed by a structural curved skin covering a given plan shape and area. Here is as an example, there is a dome or rotational shell. This is a double curvature shell which is formed by rotating a plane curved shape about a vertical axis, and this is a pendentive dome. In this dome, as we can see, there is an inscribed polygon. This dome looks like the dome, a normal dome is intersected vertically, is cut vertically in all the through all the four sides of the inscribed polygon. So you can see here this arch looks like a vertical plane along the edge of this inscribed polygon has cut a simple dome. So this is how a pendentive dome is formed. This is an example of a translational dome which is formed by a curved line moving over another curved line. This is a barrel vault. A barrel vault is, it resembles a cylinder cut through the longer axis of the cylinder. These are the combination of domes and other forms of structures. This is called a conoid shell, and this is a hyperbolic paraboloid. These are basically a combination of shells and other forms of structures put together, and we can make, all these give rise to interesting shapes and forms and different kinds of structures. This is a space deck. It's a series of interconnected inverted pyramids, and this is a space frame. This is a series of interconnected grids. All these members in the space frame, they do an important work of bringing the load from the top to the foundation. Here in this figure is a tension cable structure. Here we see there are two compression arch systems, and in between there are tension cables to support the covering on top. So this kind of structure is called as a tension cable structure. This is a tension membrane structure, or also called as tensile structure. What happens in this structure is, we generally have a network of cables forming tension membrane, and there is a covering on top like canvas, which can be used as a covering on top of these tension membranes. So it forms a tensile structure or a tension membrane structure. Moving to another kind of classification, the structures can also be classified as substructures and superstructures. Substructure. The substructure can be defined as all structure below the superstructure, which in general terms is considered to include all structure below ground level, but including the ground floor bed. What it means is, anything below the ground level can be termed as the substructure. So for example, what comes below the ground level? Below the ground level are the foundation, the load bearing walls that lead to the foundation, the columns that lead to the foundation. So all these below the ground floor bed are called as a substructure. Here there are some more examples of substructure. Here we see an example of pile foundation. So the pile foundation, the ground beam, and the wall that leads to the pile foundation are all members, are all components of the substructure system. On the right hand side, we see a service duct below the ground floor level. So all this is also part of the substructure system. Here we see a retaining wall. The ground level is at the top, then a retaining wall, and this is a paved area, and this is a basement wall, and this is a ground floor slab. This is a basement rat foundation. So all these components which are coming under the ground level are called as substructure. Superstructure. A superstructure can be defined as all structure above substructure, both internally and externally. So superstructure is nothing but all the components of a structure which are coming above the ground level. For example, our walls, the columns above the ground level, the beams, the roof, the ceiling, if the finishes, everything that comes above the ground level can be considered as parts of superstructure. Now there are various elements of a superstructure. These are basically components of the building carcass above the substructure, excluding the secondary elements, that is finishes, services and fittings. So these are the primary elements of a superstructure. So the elements of the superstructure can be classified into primary elements and secondary elements. So the primary elements would be the basic carcass, for example, the walls, the beams, the columns, the floor slabs, and the secondary elements would be the finishes or the ornamental part of the building that comes over the primary elements. So these are the various components in this illustration. This illustration describes the various components of the superstructure. Coming from the top, this is a roof. These are the external walls. This is a partition. These are the framing members. These are the beams. These are the columns. These are the galleries. This is an upper floor slab. All these are parts of the superstructure. These are the stairs and ramps. These are the internal walls. And all this you see from the ground floor level, from the top of the ground floor to the top of the roof, the parapet. All this are part of the superstructure. Coming to the secondary elements. Secondary elements are nothing but the completion of the structure, including completion around and within openings in primary elements. What I mean to say is, these secondary elements are nothing but the finished product what we see. We have a wall. The wall is a primary element. On top of it, we do plaster. The plaster is again a primary element. but on top of it we do a painting. For example, we do POP, we do painting, that becomes a part, that finish is can be called as a secondary element. For example, there are a few examples that I have brought here. For example, floating floors. We see this floor slab, this is a primary element, and we see this floor finish that is coming above the floor slab, that is called as a secondary element. This is a roof. This is another example of a floating floor. So this is a primary element and this is a secondary element. This is the RC slab of the floor, so we call it as a primary element, and this is the finish of the floor, including the framing members of the finish. So these collectively are called as secondary element. Then we come to the roof lights. The roof, as we discussed earlier, is a primary element, but the roof lights come as a secondary element. Here we see in the door jambs what happens. The door openings, in the walls are basically primary element, but the door in turn is a secondary element. Here we see the ceiling slab is a primary element, but the suspended ceiling is a secondary element. In the case of staircase, the staircases as such is a primary element, but the balustrades and the finish on the tread and risers are all secondary element. Here we see the external walls and the internal walls. What we see here is the walls basically are the primary element, like where the walls can be made up of bricks, the walls can be made up of concrete. So all these are primary element, but on top of it, when we do paneling, when we do windows, all this are called secondary elements. We do door linings, we put lights on it, so all these are part of the secondary elements. Finish, the final surface which can be self-finished. The final surface which can be self-finished, as with a travelled concrete surface or an applied finish such as floor tiles, is called finish. Finish is nothing but the final surface what we see after the construction. We can leave it as a travelled concrete or a plastered surface, or we can apply a finish on it as discussed earlier, like paint finish. We can apply floor tiles on it, we can apply different kinds of cladding on it. So whatever we put on the wall and we leave it as such, so the appearance of any element of a structure can be termed as a finish. Here we have few examples. This is an external wall, and here we have a tile hanging, a weatherboarding, a painting, or a painted surface or a textured painted surface. So all those can be called as finishes. In the internal walls, we might have wallpapers, we might leave it just plaster, but the wall is a primary element, but all the finishes are secondary elements. We can have a dry cladding on the walls, we can have wet cladding on the walls, we can have trims of various materials on the walls. So all those are secondary elements, and all those can be termed as finishes. In case of floors, here this example, you see the floor slab is a primary element, but the screed with the tiles or carpet is termed as a secondary element. We see here again in terms of wooden floors, another example. The RC slab, the structural slab of the floor, is a primary element, whereas the wooden blocks kept on it are secondary element, or the quarry tiles kept on it are secondary elements, and these are the finishes. Some more examples of finishes are stairs. The stairs, just now we discussed that the nosing trims, the tread risers, what we see after the construction is we can do stone, we can do wood, we can leave it as concrete as such, but whatever we leave, whatever we see after the construction, the appearance of every structure is called finishes. Here we see in the ceilings, it's a plasterboard and plaster ceiling, and then here we see at the ceiling, at the roof covering, these are tiles or slates. Here we see in this example, this is a roof, and then we are doing nothing but we are just pouring asphalt and metal covering over it, so that everything will also come as part of finishes. So this is an overall overview. We can call it an overview of what we have gone through so far. This is a typical domestic structural system that consists of a roof, that consists of walls, and that consists of foundation. As discussed, the truss at the top, as discussed, the structure from the top to bottom, the work of every member of the structure is to transfer the load from top to the foundation, from the top of the structure to the foundation, that is the substructure below the ground. Here we see the load of the roof coverings plus any snow and wind loads are transferred to the roof members. These loads are accepted by roof members, which are in turn transferred to the walls. We see the diagram, we see the arrow that depicts the transfer of forces. Here, the ceiling loads plus any loads in roof are transferred to the joists. So, this include, we can see a dead load kept here. There can be dead loads, then there can be live loads also. So, all these loads are transferred into the walls. The loads over openings are transferred via a lintel to the jambs on either side. After that, total floor loads are transferred to the wall. Dead and live loads of flooring are transferred to the floor joists. Further, these wall loads are transferred to the foundation. The total floor loads transferred to the internal load bearing wall are further transferred to the foundation. The ground floor loads which are transferred directly to the ground, and here at the foundations these arrows depict the total wall loads which are transferred to the mother earth through the foundations. Coming to the second example, this is an example of a typical framed structure. Here also the principle is the same. The work of every member in a structure is to transfer the load from the top to bottom. Here we will start from the top. The load of roof coverings plus any snow and wind loads are transferred to the roof slab. The roof loads are accepted by the beams, which are further transferred to the columns. The loads of infill panel are transferred to the edge beam at the base, that is here. The total roof loads are further transmitted down the columns to the other frame. The live and dead loads of floor are transferred to the main and the secondary beams further down. The main and the edge beam loads are transferred to the columns. So, all these loads are further transferred to the columns. The secondary beam loads are transferred to the main beams, and the main beams they further transfer to the load of the columns. So, the total column loads are further transferred to the foundation. So, here we see this as a description of the total forces that are transferred to the foundation, and the work of the foundation is to transfer those loads further into the mother soil. So, now coming to the external envelope. Any man-made built environment would also have an external envelope. So, this external envelope consists of the materials and components which form the external shell or enclosure of a building. These may be load bearing or non-load bearing according to the structural form of the building. Here we see in this illustration, the external envelope protects us from the natural adversities. It also protects us from sound. It protects us from excessive heat by providing us heat insulation. It gives us a comfort into our build space. Here we see in this illustration, we see that this typical external envelope protects us from the rain, from the snow, from harsh atmospheric conditions. It also protects us from sound. Here we see, we can see heat loss from here. We can see thermal insulation. This is an envelope. The envelope provides us an acceptable appearance. The openings in the envelope provide ventilation from the build space, so that the build space is properly ventilated and there is inflow and outflow of air. The envelope also needs to have an adequate strength, stability and durability, and also fire resistance. The openings also provide visual contact with outside, and the doors, an important part of the opening of the external envelope, they provide an access and egress from the built environment, from the envelope to outside. Further down, the walls at the down level, the envelope walls that leads to the foundation, that resist moisture penetration rising through the walls from the ground. These are the important components, and these are the important, this illustration depicts the important functions that the external envelope does to protect us into our build space. Here we see two other classifications: the internal separation and compartmentation. The internal separation and compartmentation is an important part of a structure. Here we would like to explain this internal separation and compartmentation through two examples. One will be dwelling houses and the other one will be flats. Now, what is compartmentation? A compartmentation is nothing but a segregation of space in the built environment. For example, in a built environment, in a room, we have a bedroom. In a space, in a square, we have two rooms, a bedroom and a drawing room. Both have different functions. So, both these rooms or both these space are separated by physical barriers like the walls. So, the space after the physical barrier that is left is called a compartment. So, the entire process is called compartmentation. In this case, the examples of dwelling houses, what we see is, we see walls, we see a roof void, we see ridge or apex of roof, and we see separate buildings. It's a complete example where we have a ground floor, we have an upper floor, we have the walls that are continuing to the roof. So, this space is segregated into different functions, like as I said, a drawing space or a dining space or a living space, but the entire space is one dwelling unit. There is another part of compartmentation in which we make compartments based on a collection of these functional spaces. For example, flats. What do we do in flats is we segregate a collection of these dwelling units. Each flat is a combination of dwelling units. Like here we see, we have a staircase. This one can be considered as one flat which is compartmentalized by the walls, and since we have compartmentalized the space with the walls, this space provides us a resistance from fire, and also provides us an acoustic value by not letting the sound come out of the space, or not letting the outside sound come into the space. So, here we see this is a collection of dwelling units that is called as flats. Point to be noted: for non-residential buildings, a compartment size is limited by floor area depending on building function or purpose group and height. Compartment, that is a building or part of a building. It's a definition. A compartment, a building or part of a building with walls and floors constructed to contain fire and to prevent it from spreading from one part to the other part of the same building or to an adjacent building. So, that is why compartmentalization is so important in any structure. Separating floor or wall. Elements of sound resisting construction between individual living units. So, what compartmentalization does is it provides us sound resistance between individual living units and to the adjacent living units. So, what we have gone through in this episode is introduction with the concept of environment, that is natural and built environment, have been discussed. The types of structures have been discussed with illustrations. I have explained the superstructure and the substructure. The component parts and their functions have been explained, and the concept of internal separation and compartmentation has been introduced. Questions: what do you understand by environment? Explain in detail about types of environment and its components with illustrations. Explain different type of structures with illustrations. Explain load distribution in structures with examples of a framed structure and a conventional dwelling unit. Briefly explain the concept of compartmentation. Thank you.